Hey everyone, let's start talking about belt friction in our discussions on friction. So belt friction occurs anytime you have like a belt, or in this case a piece of string, generally wrapped around some sort of a circular object or post. You can see in this scenario, hopefully I got that up high enough, I've got a half a kilogram here, and I've got a piece of string wrapped around this this cylinder, right? I want to put that string ahead. Now, if I pull on this so that the mass, the half kilogram mass begins to move, you can see that that takes about 8.5, not even sure what those units are, but 8.5 units of force in that spring to get that going. All right, and the other thing you'll notice here, put that back in position here, the other thing you'll notice is that the belt is in contact at the top and on the side. All right, so at the side over here and then the very top. So it goes around the belt or the string in this case goes around the cylinder through 90 degrees. All right, if I bring this down here and I start to get this thing going, keep that from swinging a little bit. Once I get it going, it takes about 10 or 11.5 for that thing to actually begin to move. So 11.5 units, and I've gone around this cylinder by 180 degrees. So 11.5 units when I go around 180 degrees, and it was about 8 or so units when I went around 90 degrees. And then, so let me just do it once more. I get this thing going, and it's about 20.5, maybe 19.5 or 19 units to get it going, and I've gone around that belt. Well, it looks like about 14.5. All right, so say 14.5 again. A lot of that goes with the coefficient of friction being slightly different on this part of the string versus the stuff towards me. But at any rate, so more than the other though, right? Right, so that the amount of force required has changed as I've increased the angle. Okay, here's 360 degrees. Lift that up. Oh yeah, and there it is at about 22 all the way around there, right? And it's finally starting to move. So the coefficient of friction is causing the force to change as the angle changes going around the belt. And so in general, if this is the cylinder around which that string, or this could be the belt on an engine of some type, like in your car there are belts. But in our scenario, we had some weight here. So I'll just label that mg. And then some tension over here. And then there was an angle in here, theta. And I used 90 degrees, and 180 degrees, and 270 degrees, and 360 degrees. And we saw that the tension required to get this barely moving, right, to just barely get it moving, changed as the angle changes. Well, it turns out that the equation between the tension required to move this weight, so let me actually relabel this just slightly. This weight is going to be equivalent to the tension on this side, so I'm going to call that T1. And then T2 is the tension over there. Okay, so T1 and the weight are pretty much the same, but the tension, there's always on one side of the cylinder and the other, there's two tensions, right? And it turns out that T2 is equal to T1 times e to the mu, where mu is that coefficient of friction, right, times the angle theta. So this is an exponential relationship. So you can imagine if I wrap that around 2 or 3 times, where mu is 2 pi, 4 pi, 6 pi, which reminds me, or theta, not mu. Theta has to be measured in radians, not in degrees, right? Theta is measured in radians. And then mu is just some number, depends on what we're talking about. It's going to be different for a rubber belt on this steel cylinder than it was for the string on the cylinder. It's going to be different for a nice rope around a wooden post Oftentimes these problems are referred to as hitching post problems because that's basically the idea behind a hitching post. You wrap it around a couple, 3 times, and the tension T2 can be very large with a fairly small tension T1. Well, T2 could be a horse or a cow pulling on one end of the rope, and T1 is the cowboy or cowgirl pulling on the rope. It takes very little tension over here to resist an awful lot of tension over there, right? And as a matter of fact, it's more likely to break the rope in many of those cases. And that's how the hitching post works, and this is how tensions around belts work. Okay, so this is belt friction. It's a pretty interesting relationship, and oftentimes we'll do an experiment in my physics class or in my statics class where we'll wrap a string around a post with a force table, and we'll look at these 2 tensions as that angle changes. It's a pretty cool little experiment. Okay, so that's belt friction in a nutshell. If you have any questions on that, please leave them in the comments below. Thank you.